Alright, so today's video is on covalent compounds, although what you're probably seeing in the screen says something about ionic. And the reason we're seeing that is because I want to kind of go back and review some of the stuff that we went over and some of the problems that I saw throughout the classes. Okay, so first of all, let's go ahead and take a look at how have ionic compounds evolved for us, at least. Where have we been with this? What do we learn? And what direction did they take? So we started off with, saying that for ionic compounds, it involves a metal and a nonmetal. For example, sodium and sulfur. Sodium is a metal, sulfur is a nonmetal. And then we put its valence electrons for each one. We said that the metal transfers electrons to the nonmetal, and we need to make sure that our metal gets rid of all of its electrons and our nonmetal has 8 around it. Once we figured that out, we would count how many of that metal we used, in this case 2, and how many nonmetals we used, in this case 1. And then we moved over to Criss-Crossing. Okay, so we had things like copper 2 chloride. I gave you an ion sheet. Okay, looks something like that, but really bright. So I gave you an ion sheet, and then you were supposed to look up the charges and cross them. So that 2 would come to the chlorine and that 1 would cross to the copper, but we never show 1s, and that would make us all happy because we did this. Okay, so then we went over how to name them. So we had a formula given to us, and it was all about working backwards. So this 3 originally was originating from phosphate. So if you cross it back, that 3 would have been here. Remember, the right hand side ion is always your anion, your negative ion, so that would have been -3. And this 2 would have crossed back, and that's your positive ion, and it would have been +2. So if you look up the ions, we would be looking at, the top ions where calcium is right here. We know that that's Ca+2, just like we notice that being here. So we're going to call that calcium. And then we look up phosphate, and we find phosphate right there. At least that's a formula. We know that's the name. And voila, you came up with the name. Okay, so the question is now, what are some of the things that I saw you struggle from this? Okay, just from doing the activity these past few days where you guys were asking me, well, help me out. Let me know what I'm doing wrong. And I told you, well, go ask your friend, your partner. Let me give you a hint. Let's kind of go over some of that stuff so that you know for a fact that that's where your mistakes were. Okay, so first of all, some of you were like, how do I crisscross? All right, so you had a name. Here's calcium. Remember, I said the first one is always positive, the second word is always negative. Then I even told you, take a look at your ion sheet. So here we go. I'm looking up calcium. Calcium, there it is. I know that's the ion and its charge, which is what you would write here. Phosphate, look it up. PO4 -3. That's where it is. So then, from here, we know this is a polyatomic ion. So if you cross any number that's bigger than 1, in this case it is, you have to put parentheses on it first, just like this. So then the 2 crosses outside of the parentheses. Remember, the 4 is still included in the parentheses. It's just that 3 and 2 that are crossing. The 2 crosses over, the 3 crosses to the calcium, and there you go. You have your new formula for calcium phosphate. Okay? Remember, always cross down. You should never have numbers floating up on here, which is what I saw some of you doing. You're never going to show pluses or minuses in your final answer. This is what it should look like. So the next problem I saw is, when do I use Roman numerals? So if you have a cation, and yes, only the positive ion will have Roman numerals, never the negative ion. But if it has more than one type of charge, then Roman numerals are definitely needed. Okay? Better yet, your ion sheet. There you go. These are the ones that more than likely will have Roman numerals. They're your transition elements. And then you have some that don't. Okay? Like sodium doesn't need a Roman numeral. Okay. Cesium doesn't need a Roman numeral. Beryllium, calcium. Okay, those are group 1, group 2. They're not within the transition, so they're good to go with just the first name. So, this oxidation number, which is where some of you didn't understand, tells you what the Roman numeral is. So if this is 1, you're going to be using Roman numeral 1 in the name. If this oxidation number or charge is 2, then you're going to use the Roman numeral 2 in the name. Here's a 2, Roman numeral 2. Here's a 4, Roman numeral 4. Pretty much, like it says here, the charge is the same amount as a Roman numeral. FYI, guys, so don't forget that if you want to go back to this, the cool thing about all this having a video is that you can always rewind, you can always pause, and go back if something is going by too fast. That's a cool thing about all this. So you can always adjust it to your own style of learning. Just thought I'd put that in there. Okay, so what about using it when we're crisscrossing? Alright, so we see cobalt 2 oxide. All I need is the symbol for cobalt, capital C, capital O. This Roman numeral we know is going to be a positive 2 charge. If this Roman numeral was 3, then that would be a positive 3. And then oxide, I can look it up. Again, ion sheet, oxide, negative 2. There it is. Okay, when you have two oxidation numbers that are the same amount, just different charges, then that means that they cancel out. So in this case, it's CO, lowercase o, capital O. And that's your formula for cobalt oxide. Okay? Now what if, this is where most of you struggled these past few days. What if I am given the formula and now I need to give the name? So what I had told you in the previous video is cut it in half. For the most part, with the exception if you have this guy right here. Okay? With the exception if you have ammonium. For the most part, your cation is going to be one element. Again, unless you have ammonium, which is 2 capital letters. Cut it in half. Find out what this ion is. What is the name or the charge of that ion? So you're going to look in your ion sheet. The closest thing to it is going to be right over here. NO3, negative 1. Okay? So I know this is NO3, negative 1. So iron happens to be a transition element. More than likely it's going to have a Roman numeral. If I look, sure enough, instinct is correct. By the way, guys, please don't use a common name on your ion sheet. Do me a favor, cross it out. We don't like using those. We like using the ones that have Roman numerals, okay? So anywho, your question should be, how do I get that to look like this? What did this number have to be to give me this as an answer? So go backwards. Okay, same thing here. This is a transition element. It's going to have a Roman numeral. Let's try and figure out the charge. We know oxygen is negative 2. What would this have to be to look like that? Same with this other one. Alright, so here you go. You have iron nitrate, which is what you see here. Okay, if you crisscross them back, go backwards, where they came from. We know this was negative 1 because we looked it up. This 3 is outside the parentheses, so that means that this came from the iron. So in this box, I made it so that you know that it's a positive 3. Okay? And if we would have recrossed it back, and this would have been a 3, you would have put parentheses, you cross the 1, we don't show 1s. That's the oxidation number we would use. So in this case, you're using iron 3 nitrate. So it would be iron Roman numeral 3 nitrate. Here, we know oxygen is a negative 2. So here you don't have any oxidation or any crisscross numbers from the oxidation numbers. So you have to ask yourself, what did this have to be to give you this answer? It had to have canceled with the negative 2. So this could have been a positive 2, and it is. to cancel, and it would have given you this answer. So copper, Roman numeral 2, oxide. Okay, with this one, you could have just crisscrossed them as well. If we would have looked at carbonate, it's a -2. That 2 was crossed here. That's why this compound has that 2. That means that 3 had to have come from the manganese. So in this case, we use manganese, Roman numeral 3, carbonate. Alright, so last but not least, trouble that you guys had is how do I simplify? And we're almost done. I know I promised that it would be less than 10 minutes. Sorry about that. I just saw a lot of problems, and so I figured that you would benefit from this, if anything. Okay, so here we go. You would cross the 2, cross the 4. So now you have 2 and 4. This is like a fraction, like 2/4. How would you simplify 2/4? That would be 1/2. So when you write this down, it's going to be Ni1, which we don't write 1, O2. So somebody asked me today, Miss Harding, why would you have to simplify? What's the whole purpose? Isn't that the same? Well, actually, it's not. And this is what I showed them. So if we were to do this the long way, remember, crisscross is only just like it's a shorter way of doing this. It's a shortcut to doing this. But if you were to do it the long way, you'd have to understand, here's nickel. Nickel has a +4 charge. We have oxygen with a -2. I would need another oxygen because that would give me another -2 for a total of -4 to cancel out a +4. So +4, -4 cancels out. So now the question is, how many times did I use nickel? 1 time. How many times did I use oxygen? Twice. So if you notice, it gives me the same answer as my simplified version, which is why, again, you should always simplify. Crisscrossing is only to make it a lot easier for you. Okay, so I know it throws some of you off whenever you were using parentheses. So here we go. There's 4 crosses, but remember this is 2 elements. It's a polyatomic ion. So before you cross, you got to put parentheses. The 4 goes out here. This 2 gets crossed. Okay. So now we still have a 2 and a 4. Never reduce or simplify anything inside of parentheses. That stays put. That never changes, okay? So you're only simplifying the numbers that were crossed. So again, 2 and 4 makes it 1 and 2. And there you go. So that's a quick review, if anything, on all the problems I saw with ionic bonding. So this is where we now move to covalent compounds. So what do we know about covalent compounds? Okay, we know it's made with 2 nonmetals. We know they share electrons. We know that these funny looking bubble bonds become straight line bonds. We know that we keep the lone pairs, and we count, just like we did before, how many we used. So we used 1 carbon, 4 chlorines, and there it is. And so what's next? From that, what else do we need to know? Just like ionic, formulas and naming. They're a tad bit different, but I promise you, you'll think they're easier. Alright, so the thing about covalent compounds is that there's no crisscrossing, there's no ion sheet, there are no Roman numerals. We're going to use what's called prefixes because they go at the beginning of a word. So these are the 10 prefixes. I suggest that you write them in your ISN, so take some time, pause it. Go ahead and write them into your ISN because you're going to need them. In fact, better yet, write them onto your ion sheet. Put this is only for covalent bonds so that when you have that handy and you're trying to do covalent and ionic bonding, they're both in the same page. Okay? Just a reminder, don't forget to write these, okay? Alright, so first thing, look at the prefixes used in the name to determine the formula. So here's your example or sample formula. Dinitrogen pentoxide. Looks complicated, right? It really isn't. So first of all, remember our prefixes. We have the prefix di. Again, di. Di means 2, hence 2. On the other word I see penta. Here's penta, means 5, hence 5. So nitrogen is derived from nitrogen, that's a symbol. Oxide from oxygen, but O is the symbol. So then here's our N, here's our O. What we're going to do is put these prefixes as subscripts to the right. Again, to the right bottom of that element. So 2 nitrogens, penta, 5 oxygens. Again, bottom right hand side. That's a left, this is a right. And that's pretty much how you would write the formula. All right, there is something I want to mention because this is one of the exceptions, and I know nobody likes exceptions, but here we go. So let's take a look at this example. It says carbon monoxide, which we've heard of it, right? It's that dangerous stuff that most people have to be worried about whenever they start their heaters. Dangerous, odorless gas, and it could kill us. But let's talk about the formula. So if you notice, there's no prefix in front of that carbon. So I put down what? No prefix, no prefix. That's because mono happens to be the only prefix. That's right, the only prefix out of these 10 that you cannot use in the first word. Okay? You can use it in the second word of the name, but never on the first word. And it's the only prefix. No other prefixes do that. Okay? So carbon, just one. Mono, one oxygen. So CO. That would be pretty much our formula. And then just a side note, notice that you'll never show a 1. Just like you didn't do in ionic compounds, you never show 1s. So as you could see, there is not a C1O1, it's just CO. Alright, so we talked about the formulas, but what about naming? And I really do mean easy peasy, that it's really not difficult, okay? So let's go ahead and take a look at how we do that. So there's a formula. How would we name it? Notice we're not using an ion sheet. Just like I told you before, no ion sheets, no Roman numerals, no crisscrossing. This is a lot easier. It really is. Okay, so first we notice that this symbol is for carbon. This symbol is for nitrogen. Now we got to figure out what the prefixes are for this number and for this number. Okay, so 8 means octa and 6 means hexa. So 8 octa, 6 hexa. All right, so the prefixes in the name are always going to go first. Prefixes, before you ever put the element name. So then when we're writing it, it's going to be octa carbon. So octa carbon, hexa, and remember this was nitrogen, but the ending for covalent compounds, they're also called molecular compounds, okay? But the ending for the second word will always be IDE. You don't have to worry like in ionic compounds that you had 8, ite, and ide. You had 3 versions of it. 8, ite, and ide. Here, they're all always going to be ide, okay? Ending is ide. So prefix goes first, like I said. Ending doesn't change for the first word, just for the second. And again, the prefix goes first in the first word. Okay, here's another quick example. Just on writing the formula, which we did prior, right? So trinitrogen tetraphosphide. So again, tri is 3, nitrogen N, tetra means 4, phosphide is P. So remember, it's got to be the letter first. This number goes again bottom right. Letter first. This number goes bottom right. Okay, so what is it going to look like? Just like that. And just on the naming again, I can't stress it enough. Notice that they all end in IDE, ide, for the second word only. The first word always stays the same. So the formula for this one is N subscript 3, P subscript 4. Okay, so I have a little note. It says, notice your covalent compounds are binary at this point. So at this point, we're only dealing with 2 elements. Okay, and we'll only deal with 2 elements. So unlike ionic compounds, let me remind you from the ones that we did. So let's look. Unlike ionic, look. 1, 2, 3, 3 capital letters. So you can always end up having more than 2. Okay? Okay, so Alexa is talking to me at night, but all right. Sorry, thank you, Alexa. All right, so here we go. With these, you'll only have to worry about 2 capital letters. All right, so just keep that in mind. That's why it's a little bit easier. All right, quick recap on what we learned about covalent compounds. Okay, covalent compounds are made with 2 nonmetals, unlike ionic, metal and nonmetal. Covalent compounds prefixes are used to name them and write formulas. Okay, yep, use these a lot. No ions, no crisscross, no ion sheet. Again, for covalent compounds. Okay, the prefix mono is never ever used on the first word. We talked about that. We can use it on the second word, just never on the first word. Okay, covalent compounds are made with 2 elements, meaning 2 capital letters. And last but not least, the first word doesn't change its ending. It's always the second word. It's going to end, or it will end in "ide" or IDE. All right, guys, that's pretty much your review to ionic compounds / how to do covalent compounds, formulas, naming tutorial. Okay, so if you have any questions, again, make sure you let me know. Come to tutoring.